Welcome to BeeGraphy. My name is Asim, and in this fourth intermediate tutorial, we are looking at image sampler. I'm going to explain what image sampler is, and then we are going to get down to scripting and check it out. So first of all, let us look at image sampler. If you just go onto Google and type in image sampler, you'll see images like this, and this is what we will try to achieve. There is an image, and then there are some geometries that represent that image. Before going into the image sampler, let us understand what is a pixel. So you've got your monitor or mobile screen in front of you. It is nothing but very small pixels that have different colors and give you an illusion of whatever you see on the screen, an illusion of a tree or illusion of an ocean's image. But actually what it is there are tiny boxes that carry different colors, which if you look from further apart become a cohesive legible image. So in your monitor screen, we have got these pixels, RGB values. In this case, it is yellow, red, and blue. Some cases it is red, green, blue values. And if all of them are fully turned on, then it looks like white. If all of them are turned off, then it looks like black. If just the red is on and the yellow and blue is turned off, then you'll see the color red, right? So this is how the pixels control the color. They're the color in that box. Okay, so and that is why there is LED display. This is light emitting diode, LED. In each of these pixels, there are 3 LEDs in each of these pixels. These small pixels that you cannot see with the naked eye, but if you magnify, then you'll be able to see all this fine LEDs inside your monitor. Okay, now I've been talking about how computer likes to work, how computer likes to think in the past 12, 13 tutorials. Computer does not understand red, blue, white, gray. Computer only understands numbers. So we convert colors into numbers. Let me show you from this example. So this, like if you look at this image, it looks like a map, a grayscale map. And in that, it is actually made from pixels. If you zoom in to just this small part, this is what you will see, which is illegible. You cannot understand anything from it. But when you zoom out, you'll be able to see the map or any of these images. And this is a grayscale image, so we'll only talk in terms of white, gray, and black. And the way to define the whiteness or the blackness of a pixel is through these numbers. You see, all the white spots are numbered 255, which is the max amount, and then 0 means black. Okay, again, this one is 0. Let's make a triangle. Try to make a triangle. This one is also black. This one is also black. This one is slightly towards white. It's not purely black, so it is 17. So you understand where we are going. The value means the whiteness of that pixel. So 255 means it is turned all the way up, and black means it is 0. So if it is in the middle, like it's a gray, it is somewhere in between, 119 in this case. So this is how the numbers are converted back to colors, or just grayscale, black and white in this specific scenario. When we are talking about colors, we've got these 3 diodes, these three lights in each pixel, RGB, red, green, blue. Now, how do we control it? We can create any color which is visible to our eyes from playing with the values, the intensity of these three colors. So if I turn off the blue colors completely and the green color completely and just turn on the red color, I will get red color. Let's say this is 255 red and then 0G, 0B. So this will become 255, 0, 0. Now this is pure red. And if I want pure blue, then this will be 0, this will be 0, and then 255 max blue. It will be 0, 0, 255. Just a nomenclature. And now if you want some color in the middle, we will put in some numbers here to get a different color, which is not red, not green, not blue, but some mixture of different intensities, and it'll give you some probably a brown color or orange or something like that. Let me show you. Let's see this one. So if you want a dark violet, the R value needs to be turned up by 148. Turn off the green diode and turn up the blue diode a lot to get the dark violet color. To confirm what I'm talking is true, we will see that the red color is 25, 0, 0, which means the red diode is on, the blue diode is off, sorry, RGB, so G. The green diode is off and the blue diode is also off. All right, so again, numbers converted to the colors. Awesome. So this is really important because image sampler is related. All right then. So we will move on to the script now. Now, image sampler is not in the not the basic node. So we'll go to the beegraphy.com. It is a plugin. So we'll go to beegraphy.com, go down, editor documentation, and you've got all plugins over here. Look at imaging. So in your case, it'll look like this. And then you click on add, and that's it. Go back to your editor, new model. Let's name it image sampler part A. Awesome. So now we have the imaging nodes over here. All right, so let us take image sampler. Just type in image and you'll get image sampler. What it needs is an image, and then there are some other inputs. You look at that. To get an image, again type in image and you will get image input. Okay, you see this is pink, this is pink, so they should match. The data type matches. In this pencil like icon, if you click on that, you will have blank here. I have uploaded some images, but in your case it will be blank. All you have to do is go to upload image, download an image from the web, and then you just have to drag and drop. So let me take this one, or just to explain things better, let me take this one. All right, so this is the gradient that goes from black to white. And if I connect it over here, it is processing that image and giving me some values. Let's see what those values are. First of all, there are 900 values. That means the scale, which is 30, is defining into how many pixels this image is being divided into. So this is 30 in the bottom, 30 vertically, so that's 900 pixels. 900 pixels. And the position of those pixels are defined by these x and y coordinates, like you can see here. And each of these pixels each of these pixels over here has some associated value that gives us the intensity, the blackness or whiteness of that pixel, how gray it is, how black it is. And then there is color. We'll look at color later on. So let's create a grid. I'm going to do that by construct point and simply put the x and y values over here. It has been created. You are not able to see it because it is pretty large. So click on this magnifying icon to see the entire grid. Let me increase the size of the viewport. All right, so we've got the grid. This image has been pixelated in such a resolution. Now what I'm going to do is something very interesting. I am going to increase the height. I'm going to lift these points up by exactly that amount that is equal to the amount of whiteness, which is the intensity. So let me do move. Right now, all of them are being moved in 1, 1, 1 direction. We are gonna take the Z vector and simply connect the intensity to this altitude. And already we are seeing very interesting results. Amazing. What has happened? The black part is at 0 level. That's 0 intensity. And the white part, you see this image has got a white border. We are seeing this white border has been raised by probably 255, the maximum number, or a lot more than that. So intensity is going on to 300, 700, and so on. Awesome. So you get the idea where we are going towards. We spoke about how computer processes an image, converts it into numbers so that it can understand. Now we are breaking in that process and using that number to associate some other transformation to make it three-dimensional in this case. So what's the practical use case? One of the use cases is Heightmap. Let me show you. This is a grayscale height map. So if you Google it, you will see several images like this. It's a satellite image or any image taken from above of mountains. The higher the mountain, the whiter it is. And all the troughs, the valleys, they are dark in color. So this is just a two-dimensional image with varying intensities, with varying white values. And now we are going to use that to create a 3D image that processes those values. I already have it uploaded. I'm just going to click on it. And you will see that it has already created those mountains from just a two-dimensional image. Now, let me show you what these things do. So gap would be the spacing between all of these points. So let us make it 50 and see what happens. It is much closer and compact. Then there is scale. So scale would increase the number of pixels. That would mean the resolution increases. It's like going from 720p to 1080p. Let's put in 40 and see what happens. Awesome. So the entire grid has increased by 10, 10 from each side. Now you can even play with this number um, further. Right now we are taking the intensity as it is and throwing it to the Z value, the move value for each of these points. We can divide it to make it more subtle. So let's put in division 2 and then see what happens. Awesome. So you can almost see the terrain. Now, right now, we are simply just pulling those points up and looking at those points. We can create a physical geometry 3D model out of this. Let's say we simply have squares and then we extrude them up according to these values. So first of all, let us create some surface. Surface. All right, so I'm going to create a rectangle and then make it a surface, and then we'll extrude that surface up. So let's do rectangle. And we will take rectangle by center because we've got all the centers. And since now we are playing with big geometries, let us reduce the scale so that the computer doesn't hang. Now I'm going to place rectangles at each of those points. Let me disconnect move. I'm going to connect the rectangles to all of the original points, and I'm going to give them width and length of which is equal to the gap. Just a second. I just had to refresh it once. So I'm going to connect the gap value to the width and length of these rectangles, and we get a perfect grid. And it's still very choppy, so I want to reduce the scale even further. And for me, it is choppy because my video recording is also going on, which slows down my computer even more. In your case, it might not hang that much. Now I've got rectangles. I'm going to create a surface from curve, and then we are going to extrude the surface up. Taking a lot of time. Let me disconnect it, and let's do extrude first. Extrude curve. Still working. I just realized instead of moving the point up, we could have simply put the intensity directly to the Z value of those points, and we would have gotten the same results. So do try it, put the intensity direct to Z value of the construct point and see what happens. It is still not working. Probably the gap is the issue. Let's put it back to 100, see what happens, and refresh it. Okay, so it's still not extruding. Now it is working. Perfect. So we are extruding it in the vector Z, and the value is same as before. Amazing. Let me give it some material. Give it black. And let's cap it because it's hollow right now. I fix the viewport. So I cap it and then I get the capped geometry into the material node. And let's hide everything else. Right click, hide. Awesome. So there we are. We've got the 3D model from this image. Now I've reduced it to 20. Let's make it 30 and see if it is more accurate. We can see these hills and rivers or valleys which are not very prominent. So let's remove the division and make the values go directly to the Z value of extrusion to see these mountains more prominent. Let's look at the image and try to orient it according to the image and see if it is accurate. I think it is like this. You see this white portion that is up. So here, that's the white portion. It's actually gray. That's why it's not very high. But on the top, we've got pretty high mountain peaks, and that is where the extrusion has been the most. And then we've got these valleys running like a V shape from here to there. Same thing over here. We've got this valley. Awesome. So you get the point how we used um, the white values, the whiteness values of the image and placed it over here. Awesome. So I want to show you another use case, which is perforations, laser cutting metal sheets, or even MDF ply, which if you look closely may not look legible. Like there are circles that are large and small, medium sized. But when you look from afar, it is a legible image, which in this case is a leopard. And in this case, we've got a motorbike. How to do that? Mm, awesome. So I'll keep this script here, and I'm going to create another script for the perforations again. Image sampler, image input. Then we will have a grid, and then we'll have circles on it, and the radius of the circle will depend on the intensity. So let's have circle from the center point. So we need an origin. So let's first construct point. So we connect the x coordinate and y coordinate to the construct point. We'll get an image. Let us take this one. And now at all of these points, you will have these circles, and the radius will be the intensity at each of these points. But I'm pretty sure the intensity is pretty big. So let's divide it by 100 and then put it into the radius. I think it is too small. So let's do divide by 50. And still nothing to be seen. right? Let's just put in 10. Now we can see something. Let's increase it a bit. Let's do 14. Nice. Let me hide everything else. Awesome. So what's happening is wherever there is white, the radius of the circle is big. And when there is black, the radius is pretty small. So we are not able to see the circles. And it gives an illusion of the image itself. So let's try some other image and see what happens. See, in this case, it looks like a ripple. Can make it more ripple-like. And the best part is even a complex image like this bird can be created. It needs more resolution. So I'm going to increase the scale to 50. And since this is not a very heavy script, there is no 3D models, we can go up in scale. You can almost see the bird now. Let's actually go to 80 now. Now it is a bit slow. But what's happening is the image sampler is taking up the image and only looking at the brightness of each pixels, no color, just the brightness of it, and putting it into the radius of the circle and giving you this image. And what you can do is download this file as a DWG format and give it to the laser cutting guy. And you can get these perforations on a metal sheet or the MDF fly board, probably using CNC milling. And then you will get these perforations which would get a legible image imposed into perforations through this small script. Right, there will be a DXF exporter that will go in the circles, and then you can simply download it from there. Awesome. So yeah, this was it for the tutorial. Just a quick recap. We looked at Heightmap, where we get an image and then get a three-dimensional structure extracted from it, from the darkness values. And then we also saw how to get an image and create perforations that look like the same image. I hope this was pretty insightful. And in the next one, we are going to look at Lego mosaic, how to create that. We'll also look at the color in the image sampler. So see you in the next one.